Subscribe to our channel, and hit the bell icon, to never miss a video from us. Hi, welcome to the AZ-204 exam preparation by test prep training. These lessons are for candidates who want to prepare for the Microsoft's Developing Solutions for Azure exam. The exam is required to become an associate level of Microsoft Certified Azure Developer. Candidates for this exam should have subject matter expertise in designing, building, testing, and maintaining cloud applications and services on Microsoft Azure. After clearing this exam, you will be eligible to take the AZ-400 exam, required to become the expert Microsoft Certified DevOps Engineer. The exam expects you to be proficient in at least one programming language. The exam expects you to have 1 to 2 years professional development experience and experience with Azure. You also need to have knowledge on developing web applications, and how to deploy web applications, and how do web applications interact. You need to know to work with Azure SDKs, Azure PowerShell, Azure CLI, etc. The responsibilities of an Azure developer can be listed as: an Azure developer participates in all phases of cloud development from requirements definition and design, to development, deployment, and maintenance, performance tuning, and monitoring. Azure developers partner with cloud solution architects, cloud DBAs, cloud administrators, and clients to implement solutions. The exam tests you on the following skills: developing for Azure Compute Solutions, developing for Azure Storage, implement Azure Security, monitor, troubleshoot and optimize Azure solutions, connect to and consume Azure services and third-party services. If you don't already have an Azure account, you can create a free Azure account. And along with the lessons, you should practice what you learn. With an Azure free account, you get 12 months of free popular services, and some credit to try and explore Azure. There are also more than 25 services which are always free. Here, when you scroll down, you can see which services you get free for first 12 months, and which services are always free. After signing in, the first thing you will see is the Azure Portal. Here you can access, build, manage and monitor everything. You can access and initiate any Azure service, manage and monitor these services, and your security and costs. Next, you will need to install the Azure CLI and the Azure modules for PowerShell. For this exam, you need to learn to work with various Azure services via the Azure command line interface, and also via PowerShell. PowerShell is a framework that can work with various Microsoft services, not only with Azure. Whereas the Azure command line interface is specifically meant to work with Azure. To use the Azure command line interface, first you need to install it. You can install the Azure CLI for the platform you are using. After you have downloaded and installed Azure CLI, open the command line for your platform. Now, to use the Azure command line interface, you first have to log into your Azure account. You can do that using the AZ login command. It is then going to open a browser where you can choose your account and sign in with that account. After you log into your account, you can issue commands that work with resources in Azure. It is a very efficient way for IT administrators to create scripts that can automatically work with Azure resources. Now, let us set up PowerShell to work with resources in Azure. PowerShell can be used to interact with various types of resources, including resources defined in Azure. So in Windows, ensure that you have opened PowerShell as an administrator. Next, we need to set the execution policy, so that we can install remotely signed packages. After this, we will install all the Azure modules. Here we are installing all of the Azure modules for the current user. After the installation of the modules, we need to import them. Now you can log into your Azure account, using the Connect AZ account. Next, let's learn what are Azure resources and resource groups. A resource refers to an entity managed by Azure. For example, virtual machines, virtual networks, and storage accounts are all referred to as Azure resources. While a resource group is a logical container for resources deployed on Azure. These resources are anything you create in an Azure subscription like virtual machines, or application gateways. By placing resources of similar usage, type, or location, you can provide some order and organization to resources you create in Azure. If you delete a resource group, all resources contained within are also deleted. You can add or remove a resource to a resource group at any time. Resource groups are also a scope for applying role-based access control permissions. The resources in a resource group can be located in different regions than the resource group. You can apply tags to a resource group. The resources in that group don't inherit those tags. A resource can connect to resources in other groups. This scenario is common when the two resources are related but don't share the same life cycle. For example, you can have a web app that connects to a database in a different resource group. Next, Azure Subscription. An Azure subscription is similar to a resource group. It's a logical construct that groups together resource groups and their resources. It serves as a single billing unit for Azure resources, and the services used in Azure are billed to a subscription. When you sign up to use Azure, a billing account is created. You use your billing account to manage your invoices, payments, and track costs. You can have access to multiple billing accounts. For example, you might have signed up for Azure for your personal projects. You could also have access through your organization's or your company's account. For each of these scenarios, you would have a separate billing account. To create an additional subscription, sign into the Azure Portal and search for subscriptions. Then select Add. If you have access to multiple billing accounts, select the billing account for which you want to create the subscription. If you don't have access to more than one billing account, you can create one. Let's see how to create a resource group in Azure Portal. You can either search for resource groups in the search bar, or select from the Navigate section. Then select Create. Then give your resource group a unique name and select a region. Then just go to Review and Create. Now let's see how to create a resource group using Azure CLI. 1. Connect to your Azure account. Since you're working with a local install of the Azure CLI, you'll need to authenticate before you can execute Azure commands by using the Azure CLI login command. 2. Create a resource group. You'll often need to create a new resource group first, before you create a new Azure service. Execute the command, group create, followed by the name and region. 3. List. The following CLI script lists the resource groups under your subscription. Now, to create a resource group using PowerShell, use the following commands. Now we will move to our first module for this exam, which is Develop for Azure Compute. So let's get started. First is Azure Virtual Machine. Azure Virtual Machine gives you the flexibility of virtualization computing resources without having to buy and maintain the physical hardware that runs it. However, you still need to maintain the virtual machine by performing tasks such as configuring, patching, and installing the software that runs on it. You might require virtual machines for various tasks. Some examples are development and testing. With virtual machines, you can quickly and easily create a computer with specific configurations required to code and test an application. Next is cloud applications. Since there are always fluctuations in demand for an application, it makes economic sense to run it on a VM. You pay for extra VMs when you need them, and shut them down when you don't. Another example is an extended data center. Virtual machines in a virtual network can easily be connected to your organization's network. The following aspects of a VM are important to think about before you start. 1. The names of your application resources. 2. The location where the resources are stored. 3. The size of the VM. 4. The maximum number of VMs that can be created. 5. The operating system that the VM runs. 6. The configuration of the VM after it starts. 7. The related resources that the VM needs. 8. You might require virtual machines for various tasks. Some examples are: when you deploy a virtual machine on the Azure platform, there are a number of other resources which are deployed along with the virtual machine. First is a virtual network, where the virtual machine resides. 2. In addition to the virtual network, we need an OS disk, assigned to the virtual machine, and used for holding the OS level data. You can also add your own data disk on the virtual machine. 4. A virtual network interface card. All of the packets of data that's sent by the virtual machine and received by the virtual machine goes via this network interface. The network interface can get a private and a public IP address. Lastly, we have a network security group, which is assigned to the network interface card. It is like a firewall, used to decide what type of traffic flows in and out of the virtual machine. Here is a diagram showing a deployed virtual machine with its components. Now, in next chapter, we will learn how to deploy a Windows VM. In this chapter, we will learn to deploy a Windows virtual machine in Azure. You can create any new resource through this New Resource button. Or you can also select the service directly and click on Create. Let's create a new VM now. Now we will select the subscription we want to add this resource to. So this resource will be built against this particular subscription. We can also add a new resource group here, or add this resource to an existing resource group. And give a name for the virtual machine. Then select a region. For now, we will leave the availability options. Next, in the image selection, you have different options to select for images. You can select an image from the drop-down menu, or check the list of images available. And select one according to your needs. Here in the search bar, we will search for available Windows servers, and select a Windows 2019 data center server. Next, we can select the size of the VM as per our requirements. When you select an image, you will be shown an estimated cost of that machine, which is calculated for a machine which runs over a month 24/7. Next we will give it a username and password, which will be used to log in to this virtual machine. Now, in the inbound port rules, we will add a rule to allow traffic on the port 3389. By default, traffic is not allowed to flow into the virtual machine. This is kind of a security boundary. You then create a network security group rules to ensure flow of traffic into the virtual machine. Here, it is automatically adding a rule to allow traffic on port 3389. This is the remote desktop protocol port for the Windows virtual machine. This will then allow us to log into the virtual machine. Next is the disk section. By default, you will have an OS disk that will be assigned to our virtual machine. Now we can choose the type of disk for our OS. If you want high performance, you can keep the default SSD. These disks have encryption enabled by default. Additionally, there are different disk types that are available in Azure for additional usage as per our needs. For example, if we have an application on our virtual machine, that application needs to store data. So we can add an additional data disk for the storage of this data. Also note that, you can add a data disk later on too, even when the virtual machine is in the running state. Now next is networking. Now here, a virtual network is created for you. Since our virtual machine needs to be part of a virtual network. If you already have an existing virtual network, you can also choose that. And note that, the virtual network is a separate resource that's gonna get created along with this. This virtual network and your virtual machine will be created in the same region. Next, for each virtual network, we have a subnet. And we have a public IP address. Now we'll leave the other settings as they are. Next, there are a lot of other settings available for this virtual machine. For now we will leave them as it is, and click Next, to reach the Create section, and then hit on Create. You will get a notification about the deployment. Once the deployment is complete, you can see the details of this virtual machine in its overview section. Now, if you go to All Resources, you can see that there are quite a few resources that were created along with the virtual machine. Now let's move on to learn how to connect to this virtual machine. Now, in this chapter, we will learn how to connect to your virtual machine. You can go to the Overview section of your virtual machine, either through All Resources section, or through the Virtual Machine section. Then select the virtual machine you want to connect. First, ensure that your VM has a public IP address. Next, hit on Connect. And select RDP. RDP is a remote desktop protocol. So, go ahead and download the RDP file. Then open it. It will ask you your username and password. Click on Yes for trusting the server certificate. And now, you can see, we are connected to our Windows virtual machine. When you connect to a Windows Server virtual machine, by default, you'll get the Server Manager dashboard. This Server Manager is used to perform all these tasks on your virtual machine. You can check and see that you can also use the internet from this virtual machine, and you can also install applications, and can host your workloads on this virtual machine. Now, if you go to the File Explorer, you will see that you have two volumes. The first volume is your OS level disk. And then you have a DMB storage that comes along with the virtual machine. Now, in this lesson, we will see how to install an Internet Information Services, which is a web server, on your virtual machine. So, here we are already connected to our virtual machine. And, we are on our Server Manager dashboard. In case, if you can't see Server Manager, you can go to Windows, and here you can find your Server Manager. Server Manager is used to manage the server itself. Now click on Add Roles and Features. This will bring up a window to add the roles and features. Then, click on Next. Select Role-Based or Feature-Based Installation. Click on Next. Choose Default. And click on Next. Now, here, choose Web Server. as this is the role that we want to install. Then click on Add Features. Then Next. And leave all the settings as they are. Click on Next. And on the last window click on Install. Now it is installing the web server feature on this Windows virtual machine. After installation is complete, hit on Close. Now, if you open Internet Explorer, and go to the local host, you will see the home page for Internet Information Services. Now remember this, the web server on our Windows virtual machine listens on port 80 by default. Now, if we go back to the Azure Portal, we should also be able to browse for Internet Information Services by taking the public IP address of the virtual machine. Because the public IP address is used to interact with the virtual machine from the Internet. So place the public IP address on a new tab. So here, we are not getting the homepage for Internet Information Services. And that is because of the Network Security Group. The Network Security Group is like our virtual firewall. If we want to allow traffic to the virtual machine, we should do a change to the Network Security Group. So let's go to the networking section. Here, you have a set of rules. Now, add an inbound port rule. And leave the source and the source port range as it is. And, in the port range, allow traffic on port 80. Since the Internet Information Services listens on port 80. Then, select the protocol TCP. And just change the name of the rule, and click on Add. Once you add the rule, you will be able to see the home page for Internet Information Services. So now, you can start installing applications, or your workloads, on your Windows virtual machines. In this chapter, we are going to learn to create a custom image, based on a virtual machine. Let's assume, you have a virtual machine with some already installed application components, and some configuration. And you want this base configuration for one or more virtual machines you are going to create. So, you can actually create an image out of your already installed virtual machine, and then create more virtual machines based out of that image. This process of creating an image is known as the generalization of a virtual machine. Let's see how we can do that. Let's go to our virtual machine. This VM already has Internet Information Services installed. Now let's say, we want to create an image out of this particular virtual machine. Please, note that, when we create an image from a virtual machine, that virtual machine can't be used after that. We can use the image but not the virtual machine itself. Now, first connect to the virtual machine, to prepare the system, to create an image out of it. Then, on the virtual machine, open Windows Explorer. Go to the location. C Drive, Windows, then System 32. There, you will see a tool sysprep. And, we need to run this. This will prepare the system, so that an image can be created out of the system. Now, click on Generalize, and in the Shutdown options, make sure to click on Shutdown, and then click on OK. After this, we will not be able to use this virtual machine anymore. Now, after some time, when the sysprep tool has finished running, you'll be disconnected from your remote session. After this, we have to stop the virtual machine, and make sure that the machine has been deallocated. Now, Once the virtual machine has been deallocated, you can create an image by using the capture button here. Then fill in these details. And here, you can save it as an image version in Image Gallery, or choose to share just as a managed image. An image gallery, like the Azure Marketplace, is a repository for managing and sharing images, and you control who has the access. Now, go to your image. And you can create a virtual machine out of this image. Everything else remains the same. We will include the port 80 also. Because, remember, in our virtual machine, from which we created this image, we had Internet Information Services installed. So when we now create a new virtual machine out of this image, we will already have Internet Information Services installed. So now, once the new virtual machine is deployed, we can take the public IP address and directly can see Internet Information Services. Also, you can find your VM image by searching image in the search bar. Your created images and image versions gets saved here. So we will go to image versions and here we can see our VM image. To create a custom image from a VM using the PowerShell, use these steps. 1. Create some variables. 2. Make sure the VM has been deallocated. 3. Set the status of the virtual machine to generalized. 4. Get the virtual machine. 5. Create the image configuration. 6. Create the image. In this lesson, we will learn, what is an Azure Resource Manager? Azure Resource Manager is the deployment and management service for Azure. It provides a management layer that enables you to create, update, and delete resources in your Azure account. Now, to automate deployments, and use the practice of infrastructure as code for Azure solutions, we use Azure Resource Manager templates. An ARM template is a JavaScript object notation file that defines the infrastructure and configuration for your project. The template uses declarative syntax, which lets you state what you intend to deploy, without having to write the sequence of programming commands to create it. In the template, you specify the resources to deploy and the properties for those resources. Within your template, you can write template expressions that extend the capabilities of JSON. These expressions make use of the functions provided by Resource Manager. The template has the following sections. 1. Parameters. To provide values during deployment that allow the same template to be used with different environments. 2. Variables. To define values that are reused in your templates. They can be constructed from parameter values. 3. User-defined functions. To create customized functions that simplify your template. 4. Resources. To specify the resources to deploy. 5. Outputs. To return values from the deployed resources. Now, if you want to deploy a custom template, you can search template on this search bar. You can create a custom template from here, or you can choose custom templates from the Azure Marketplace too. Here you can either create your own template in the editor, or you can use the commonly used templates. You also have the option of choosing from GitHub. Now let's create a Windows virtual machine using an existing common template. Now here, you can edit the parameters. And here you can edit the template. If you go to the Edit Template, you can see the entire JSON template, which is used to create this virtual machine. You can see that it is a long template. Because, when you create a virtual machine, you need to have a storage account, a public IP address, a network security group, a virtual network, and a network interface. And also, the template can either create all of these resources from scratch, or it can use existing resources. Thus, if you have an existing virtual network, you can ensure that this template refers to that existing virtual network. You can also download it for automation purposes from here, or you can do it later also. Now it is deploying your Windows virtual machine. Earlier when we created a Windows virtual machine, we had to go through a list of steps. The difference now is that everything is now embedded as JSON code in a template. So you can download this template, you can reuse it, you can deploy it using the PowerShell and Azure Portal as well. So when you have a requirement of deploying similar types of virtual machines, then it makes much more sense to have a template in place and use to create resources. Now we can see that our resources have been created from the template. If we go to Virtual Machine section, we can see our virtual machine too. Also, if you want to use any other resource as a template, you can go to that resource and download it for automation purposes. Azure App Service is an HTTP-based service for hosting web applications, REST APIs, and mobile backends. You can develop in your favorite language, be it .NET, Java, Ruby, Node.js, PHP, or Python. Applications run and scale with ease on both Windows and Linux-based environments. With App Service you can add security, load balancing, auto-scaling, and automated management to your application. You can also take advantage of Azure's DevOps capabilities, such as continuous deployment from Azure DevOps, GitHub, Docker Hub, and other sources. With App Service, you pay for the Azure compute resources you use. The compute resources you use are determined by the App Service plan that you run your apps on. The Azure App Service environment provides a fully isolated and dedicated environment for securely running App Service apps at high scale. This capability can host Windows web apps, Linux web apps, Docker containers, mobile apps, and functions. Here are some limitations, which you should remember. 1. App Service on Linux is not supported on shared pricing tier. 2. You can't mix Windows and Linux apps in the same App Service plan. 3. Within the same resource group, you can't mix Windows and Linux apps in the same region. In this exercise, we will see how you can deploy an application using Azure App Service. First, search for app services, and then create an app service resource. Now, select your subscription, resource group and give your app a name. Here, we will create a separate resource group for our app. Now here, you can select the method you want to use to publish your application. We will select code. Also, when publishing your application as code, you must configure runtime stack to prepare your app service resources to run your app. So now select the platform on which your application will run. Select your operating system and region. Now here, select an app service plan. Also, remember that Azure doesn't let you mix Windows and Linux apps in the same app service plan. And also, within the same resource group, you can't mix Windows and Linux apps in the same region. By default, the wizard will create a new plan in the same region as the web app. Now here, we can select the pricing tier of the plan being created. This determines the performance characteristics of the virtual servers that power your app, and the features it has access to. We will select a plan for testing purpose. And then create your app service. Once your deployment is complete, you can see the details of your app service on its overview page. And you can copy the URL and see that your web app service is up and running. Now let's create a sample app and deploy it on our Azure App Service. So here, we have the code for creating and deploying a basic ASP.NET app on Azure App Service. So for this exercise, we will write our code on Azure Cloud Shell. First, let's install the appropriate version of .NET into the Cloud Shell. Next, running the following commands will create a basic ASP.NET Core MVC application, named Best Buy Cap. The next command will create a new folder named Best Buy Cap to hold our project. Running the following commands will change the project folder, and then we will run the application to verify it is complete. So, we can see that our app is complete. Let's now deploy it on Azure App Service. We will deploy it with a zip file. First, we will use .NET Publish to build our final app files, and then package them into a zip file. Finally, we will deploy with following code. Don't forget to replace your unique app name and your resource group name. Once your app deployment is finished, you can go to our app URL, and you will see that your app is up and running. The other methods for deploying an app on Azure App Service can be divided into automated and manual deployment methods. You have several options available, like GitHub, Dropbox, Visual Studio, pushing through FTP, etc. Azure Storage Account. An Azure Storage account contains all of your Azure Storage data objects, like blobs, files, queues, tables, and disks. The storage account provides a unique namespace for your Azure Storage data that is accessible from anywhere in the world, over HTTP or HTTPS. Blob storage. So blob storage service is used for object-level storage in a storage account. Means, you will use the blob storage for any type of object that you want to store in a storage account. Let's say you have an application, and your users use this application to upload videos, photos of images. Your application could be hosted on your on-premise environment, or it could be hosted on an Azure virtual machine. But you cannot store those images or videos on the VM itself. Because this could be a point of failure. As, if your VM goes down, you will lose the data. Another point to consider is the size of storage required. Solution is to use blob service in Azure storage accounts. So, the key benefits of blob storage are: first, decoupling, which means that your service which is hosting your videos is separate from your application and your virtual machine. So if it goes down, you still have the files in the storage account. Next, it is a highly available, highly reliable and highly scalable service. So you don't need to think about the amount of storage in the storage account. This is automatically managed. It is also used for storing your disk files for your virtual machine. The Azure disks are block-level storage volumes for Azure VMs. Blob storage is ideal for the following. 1. Serving images or documents directly to a browser. 2. Storing files for distributed access. 3. Streaming video and audio. 4. Writing to log files. 5. Storing data for backup and restore, disaster recovery, and archiving. 6. Storing data for analysis by an on-premises or Azure-hosted service. Blob storage offers 3 types of resources. First, the storage account itself, then, a container in the storage account, and then, a blob in a container, which contain your files. With Azure Storage, you have the option of following tiers. 1. Hot storage, optimized for storing data that is accessed frequently. 2. Cool storage, optimized for storing data that is infrequently accessed and stored for at least 30 days. 3. Archive storage, optimized for storing data that is rarely accessed and stored for at least 180 days with flexible latency requirements. So now let's create a storage account. So search for storage in the search, select storage accounts. Then, choose your subscription and resource group. Then, give a unique account name. Now in the performance, you choose the type of storage you want. Standard storage accounts are low cost and backed by magnetic drives, while premium storage account is backed by solid-state drives. Now here, we select the type of storage account we want. Now next you have an option for replication strategy. This ensures that your data is always replicated, and hence providing high durability and availability. Now in the Advanced tag, you have some settings for your blob storage. We will keep blob public access as enabled. So once you are familiar with storage accounts, then you can keep the blob public access as disabled. And we will keep the access tier as hot. Next, click Review and create your account. Once your account is deployed, go to the Overview section. And now, here you can see that you have the ability to use all of the 4 services. Here you have the container service, the file share service, the table service, and the queue service. Now let's create a new container. For now, leave the public access level as private. So now, go to the container, and let's upload a file. So we'll upload a file from our local system. Now, as the file has been uploaded, let's click on the file. Here in the overview, we can see all the details of this file. Also, every blob in a storage account will get a unique URL. So let's copy this, and go to a new tab. And when we put the URL, it is giving us an error, saying that the resource is not found. So this is because we are trying to access the blob as an anonymous user, and we have not given access to the blob in our container. So, if we want to give access to any other user, we need some sort of authentication or credentials for giving access to this particular resource or this particular blob. Now, one way is to give access to our container. You can do this by clicking on Change Access Level. So now let's see how you can give access to the storage account in another way. Now, if you go to Access Keys, by default, you get 2 keys. So Access Keys gives you another way to access your storage account. Now, the reason why there are 2 keys is just for security purposes, in case one key is compromised. Next, we also have something called the Storage Explorer from Azure. It is a free downloadable tool, and it can be used by you, or anyone, to access the storage, just by using the account credentials, or by using the access keys. For more such videos, subscribe to our channel.